India is the first country in the world to land a spacecraft near the moon's south pole. A moment of history for the country. It was a tense final 6 minutes as it descended onto the lunar surface.
India's Chandrayaan-Three mission found something on the moon so shocking that even Neil deGrasse Tyson can't explain it. The mission discovered a strange new element deep in the moon's south pole, an element that might not be like anything we've ever seen before. Let's dig deeper into the fact that the moon may not be as dormant or harmless as we once thought. The secrets NASA didn't reveal. Back in 1966, the Soviet Union's Luna 9 became the first mission to land on the moon, kicking off an era of exploration that would continue for decades. Luna 9 was not just any spacecraft. It was equipped with a bunch of gadgets, including a television camera on a rotating platform. This setup allowed Luna 9 to snap some pretty amazing pictures of the moon. The images showed craters, hills, and landscapes that looked completely alien to us. These photos were big news, stirring up fascination with the moon and making headlines worldwide. But within those early images lay a hidden detail that would puzzle scientists for years. This old Soviet mission brought us data that really helped us understand the moon's extreme conditions. The temperature was crazy, minus 153 degrees Celsius at night and a sweltering 123 degrees during the day. It highlighted just how different the moon's environment is from Earth's. Radiation levels were also measured, and scientists found out that the radiation was far higher than on Earth. Information that is crucial if anyone wants to think about living up there someday. Luna 9 even performed some simple tests on the moon's soil. It used a rod to press on the surface, finding that the lunar soil was surprisingly strong. This might not sound super exciting, but it was a big deal back then. It suggested that the moon's surface could probably support future landers and maybe even rovers. But Luna 9 did not last long. Its batteries died after about 3 days, but those 3 days gave scientists more data than they had ever had before. The Apollo 11 mission in 1969 was a major milestone that changed the game. Neil Armstrong, Buzz Aldrin, and Michael Collins set out from Kennedy Space Center, and Armstrong became the first human to walk on the moon's surface. They brought a whole bunch of scientific instruments and performed experiments, including placing a seismometer to measure moonquakes and setting up a reflector to measure the distance between the Earth and the moon. Their journey was not all about glory and footprints. It was very science-focused. They collected moon rock samples, which were then analyzed to learn about the moon's formation and even Earth's history. Their findings challenged a lot of assumptions. They discovered that the moon has a super thin atmosphere made of helium, neon, and argon. They also found regolith, a layer of dust that blankets the moon's surface, created by countless meteorite impacts over billions of years. This dust told stories of the moon's turbulent past and gave clues about its geological activity. One of the big surprises from Apollo 11 was finding that the moon did not have a global magnetic field like Earth. This was strange, and it raised questions about how the moon formed and evolved. There were also hints of water ice in the permanently shadowed craters at the poles. The moon, which everyone thought was just a dry, barren place, suddenly seemed to hold more secrets. Water could mean a lot for future moon missions. It is not just for drinking, but could be split into hydrogen and oxygen, key ingredients for rocket fuel. Fast forward to Chandrayaan-Three in 2023. India aimed for the moon's south pole, a region that has been barely explored, but is thought to hold many secrets. Unlike most missions that landed in relatively easier spots, India went straight for the most challenging place. The south pole of the moon is full of deep craters that have never seen sunlight, and it is believed that these craters could hide significant amounts of water ice. Chandrayaan-Three consisted of an orbiter and a lander named Vikram. The orbiter's job was to map the lunar surface from above, while Vikram was designed to land and study the environment up close. The orbiter carried 8 scientific instruments, all working together to scan the moon and collect data about its surface and thin atmosphere. Vikram had its own set of tools, focused on examining things like temperature changes, seismic activity, and even the makeup of the lunar soil. One of the most striking things Chandrayaan-Three discovered was a kind of mystery element deep in the moon's south pole region. It is not entirely clear what this element is, but some are suggesting that it could be something we have never seen before. This kind of find has got everyone's attention. It is a bit eerie, really. Imagine an element that has been sitting there for billions of years, completely unknown to science until now. The mission also revealed more evidence of water ice hidden in those dark, cold craters. This is a huge deal. Water on the moon is not just a scientific curiosity, it is the kind of discovery that could make long-term moon missions possible. It means future astronauts might be able to get water directly from the moon instead of lugging tons of it from Earth. And if there is enough of it, they might even produce fuel for missions deeper into space, like Mars. But what about the stuff Neil deGrasse Tyson hinted at? There is a theory going around that NASA might have had some idea about these potential resources or anomalies at the South Pole, but kept quiet about it. Why? Well, space exploration is as much about politics as it is about science. Nations compete for these discoveries, and sometimes information is held back for strategic reasons. It is possible that what Chandrayaan-Three found, these strange new elements or clues about water, was something NASA already suspected but never openly discussed. After landing, new findings started to come in, suggesting the moon might be more active than we thought. Moonquakes and hidden forces. Chandrayaan-Three also recorded some seismic activity, adding a new dimension to our understanding of the moon. Moonquakes. Who would have thought? These tremors are unlike the earthquakes we experience on Earth, but are significant enough to provoke questions about the moon's geological processes. Could there be ongoing activity beneath its surface that remains a mystery? Perhaps our nearest celestial neighbor isn't as inactive as we once assumed. The implications of these findings are profound. They reveal that the moon still holds countless secrets despite decades of exploration. The mission's discoveries highlight the potential of the moon as a springboard for future space endeavors. Establishing a lunar base, potentially powered by its water and energy resources, could make interplanetary travel, such as a journey to Mars, far more achievable. Our rocky satellite might become humanity's gateway to the cosmos. What has captured global attention from India's exploration efforts? It's a combination of groundbreaking discoveries, evidence of water, unusual new elements, and the revelation that the moon's south pole is far more intriguing than previously imagined. This isn't just about scientific fascination. These findings could transform how we perceive the moon, not as a barren, lifeless rock, but as a pivotal asset for humanity's spacefaring future. India's lunar mission serves as a reminder that the moon still holds countless unanswered questions. It challenges the global space community to adopt fresh perspectives and push the boundaries of exploration. As India deepens its exploration of the moon, the world watches closely, eager to learn what other secrets lie hidden in its shadowed craters and dark plains. The moon's south pole is no ordinary sight. It's one of the most captivating regions on the lunar surface. Because of the moon's axial tilt, some areas of the south pole remain in perpetual darkness, never touched by sunlight. These shadowed craters have temperatures so low they can trap volatile substances like water ice for billions of years. This pristine ice offers a window into the history of the solar system, captivating scientists for decades. Reaching the South Pole, however, is no simple feat. Its rugged terrain, steep slopes, and deep craters make landing a spacecraft extremely challenging. Unlike earlier missions that targeted relatively flat equatorial areas, India took on this formidable challenge and succeeded in landing a spacecraft in this region, opening a new frontier for exploration. One groundbreaking discovery was the confirmation of water ice in the eternally shadowed areas. Instruments on board detected unmistakable signs of ice, and the lander's surface readings confirmed its presence. This discovery is monumental because water is essential for sustaining human missions. It can be used for drinking, generating oxygen, and producing hydrogen for rocket fuel. Utilizing local resources for space missions, a concept known as in situ resource utilization, could revolutionize the cost and complexity of exploring space. Another fascinating find was the detection of a previously unknown element or mineral in the South Pole region. Although the details are still unfolding, this discovery has intrigued scientists worldwide. Could this be a new mineral formed under the moon's unique conditions, or an element unlike anything found on Earth? Such a find could reshape our understanding of planetary formation and the solar system's early history. The detection of seismic activity, or moonquakes, is another significant revelation. While the moon lacks tectonic activity like Earth, it does experience tremors caused by factors such as tidal forces between Earth and the moon. However, some of these quakes remain unexplained. The data suggests the possibility of residual geological activity, offering fresh insights into the moon's internal structure. The South Pole also appears rich in certain metals, with higher concentrations of magnesium, aluminum, and iron compared to other lunar regions. These metals could play a critical role in constructing infrastructure on the moon itself. The vision of using lunar materials to build bases, once purely science fiction, is now edging closer to reality. The study of regolith, the loose material covering the lunar surface, also yielded fascinating results. The lander found that the regolith in the South Pole region is thicker and has a unique composition compared to other areas of the moon, likely due to the distinct conditions in permanently shadowed regions. This information is crucial for planning future missions, from landing spacecraft to enabling mobility on the moon's surface. One of the most thrilling prospects stemming from these findings is the potential to use the moon as a launch pad for deep space exploration. Its low gravity makes it an ideal site for launching missions to destinations like Mars. With a sustainable lunar base supported by local resources, humanity's dreams of interplanetary travel become increasingly tangible. These recent discoveries bring us closer to turning those dreams into reality. With initial progress made, the mission's next phase aimed to dig deeper into the moon's South Pole. Big results on a small budget. They equipped this mission with the instruments necessary to collect data that could give a better understanding of the moon, setting up an ambitious foundation for future lunar research. Pragyan, the rover, lived up to its name, which means wisdom in Sanskrit, by setting out to explore the moon in precise detail. Pragyan was focused on using its two scientific instruments to gather as much information as possible. It aimed to find out what minerals were present on the moon and analyze the soil. Essentially, it was trying to solve the moon's mysteries. And the lander Vikram did not have an easy start either. On August 23, 2023, Vikram's big moment came after a long dance around the moon, piloted by Chandrayaan-Three's orbiter. Vikram separated from the orbiter and faced the challenge of making a precise landing. Not just any landing, but one that required it to gently touch down on an incredibly difficult part of the moon's surface. Imagine trying to land a spacecraft like balancing on a tightrope, except in space. Vikram had to slow down from a very fast speed, almost 2 kilometers per second, using thrusters to almost stop entirely before touching down. And it was not just about slowing down, the lander also needed to adjust its path and orientation while approaching the moon. Just like a pilot carefully adjusting before landing, Vikram made some last-minute maneuvers to make sure it landed safely. It had to avoid craters and find a spot between two specific ones, Celis N and Menina Ca. This was not easy considering the region had bone-chilling temperatures around minus 240 degrees Celsius and hardly saw any sunlight due to the landscape. With all these difficulties, it is impressive that Vikram managed to nail that landing. It was a major achievement for the mission and a testament to how well prepared the mission team was, showing that India could handle lunar operations even under the toughest conditions. They picked this landing spot deliberately because it is a region that could offer crucial clues about the moon's makeup, geological features, and more. As soon as Vikram landed, it got right to work, smoothly deploying its solar panels, like stretching out its wings after a long flight. And these were not just for show, they were crucial for keeping everything running. After the panels were out, Vikram also extended antennas, setting up communication with the orbiter. This connection was the lifeline that ensured scientists back on Earth could keep up with what was happening on the moon. The lander's work was not just about landing, though. It still had a lot to do, and the mission was just getting started. Vikram needed to let the dust settle before the rover could begin its journey. Pragyan, the rover, waited patiently for the signal to get moving. Once it got the green light, it rolled out with a sense of curiosity, like an explorer setting foot on an untouched island. But Pragyan did not have all the time in the world. A lunar day is only about 2 weeks on Earth, which was the amount of time it had to explore. Pragyan was built to move about half a kilometer from Vikram, and it had cameras and sensors that acted as its eyes and instincts. It needed these to make sure it did not run into obstacles or get stuck on the rocky surface. All of this was happening with a budget that is truly remarkable in comparison to others. The Chandrayaan-3 mission operated on $74 million. To put that into perspective, Russia's Luna 25 mission had a budget of about $200 million, and it crashed. NASA's Viper rover is projected to cost $433 million, and China's Chang'e 4 mission cost about $180 million. India's mission was a fraction of these costs, but it achieved milestones that could hold their own against much more expensive missions. How did they do it? Well, Chandrayaan-3 was light, just 1.4 tons for both the lander and rover, which was much less compared to NASA's Viper rover. Keeping things lightweight meant lower costs for launch and fuel. But it was not just about weight. They also saved by reusing technology. Instead of building new from scratch, they improved on the designs from the earlier Chandrayaan-2 mission, which failed to land successfully in 2019. Using the reliable GSLV Mk3 rocket, India's most powerful rocket, also contributed to the cost efficiency. Even though they had a modest budget, the Chandrayaan-3 mission was anything but easy. From launching to landing, the team had to get everything just right. On August 15, 2023, the spacecraft launched from the Satish Dhawan Space Center, but getting into the correct orbit around the moon was no simple feat. They had to carefully use the engines and gravitational forces of both the Earth and Moon to make sure they were positioned perfectly. They were not just aiming to orbit the moon, they wanted the South Pole, a place where they hoped to find ice and other valuable resources. Landing near the moon's south pole is not like landing anywhere else on the moon. This area has rough terrain, extreme temperatures, and very little sunlight. It was crucial to pick a good landing site with just enough sunlight and a spot that made communication with Earth possible. This all came to a head on August 23rd, when the lander had to pull off what was called the 17 minutes of terror, a time where it had to slow down quickly and make split-second decisions about how and where to land. With no real-time help from Earth, Vikram managed to do it, setting the stage for Pragyan to explore. Pragyan had its own issues to tackle. Moving on the dusty and rugged terrain was no easy task. It had to make sure it did not get stuck while also keeping the communication line with Vikram intact. The clock was ticking, with only 14 Earth days to complete its tasks. In that time, the rover studied the lunar soil, measured temperatures, and collected all kinds of data, information that could help researchers learn more about the moon and plan for future missions. The challenges on the moon are very different from those on Earth. Temperatures vary wildly, from minus 180 degrees Celsius to over 100 degrees Celsius. Pragyan and Vikram also had to deal with unpredictable communication blackouts and the constant risk of solar radiation. Managing power resources was a big challenge too, especially since there is no atmosphere like Earth's to help regulate temperatures. But despite all of these hurdles, Chandrayaan-3 pushed forward, showing the world what could be done with determination and careful planning. Neil deGrasse Tyson, the astrophysicist, had expressed enthusiasm for the Chandrayaan missions before, highlighting that it was not just about success, but also about pushing the limits of what humanity could learn. Even though Chandrayaan-2 did not succeed in landing, it was not the end. It was motivation for India to try again, which they did, and they succeeded. The discoveries made during the Chandrayaan-3 mission were groundbreaking. Tyson mentioned that the south pole of the moon holds untold secrets, such as potential water ice deposits, which could be crucial for future missions. The lunar rocks in this area are also like time capsules, preserving history that could offer insights into the moon and Earth's shared past. Chandrayaan-3 managed to land on the near side of the moon at a place called Shiv Shakti Point, about 600 kilometers from the South Pole. This near-side location presented its own challenges, like rugged landscapes filled with large craters and trenches. And the lack of sunlight near the South Pole, some areas have not seen the sun for over 1 billion years, made it difficult to generate energy for the lander and rover. Temperatures in the area dropped as low as minus 230 degrees Celsius, which threatened the electronic systems of the spacecraft. Still, within the limited time frame, Vikram and Pragyan conducted many experiments and collected important data. They studied the moon's exosphere and ionosphere, and even detected what seemed to be a moonquake. The presence of sulfur was also confirmed, a significant discovery since sulfur's presence could point to geological processes that might help us understand more about the moon's past. The hunt for water ice continues though. Chandrayaan-1 back in 2008, had detected signs of water-bearing molecules at the poles. But despite all their efforts, Pragyan did not manage to directly detect water ice this time around. There are a few possible reasons for this. The rover might have landed in an area that did not have any water ice, or maybe the ice is buried beneath the surface, hidden from easy detection. Still, the mission was successful in its primary goals. It landed softly on the moon and collected invaluable data, expanding our knowledge of lunar conditions. Now, with Chandrayaan-Three's success, India has turned its attention to the future, collaborating with Japan on Chandrayaan-4 to go back and explore the elusive water ice directly. Chandrayaan-3 proved that with a combination of resilience, creativity, and good old-fashioned determination, space exploration could be done on a budget, something that might inspire more countries to follow suit. Did Pragyan really miss the water ice? Or is there more beneath the surface than we think? Let me know your thoughts in the comments, and don't forget to like and subscribe.